Hey everybody, welcome back. Today's video is one of my favorite topics that I actually get to teach every year in algebra. So I'm a little bit bummed that I've got to do it remotely like this, but nonetheless, I do want to discuss it because it is one of the important tenets in algebra. What we're looking at today is how do you factor polynomials that are in the form that says x squared. You can't see it because it's under the little clipboard there. X squared plus bx plus c. So if you watch my last video, we would take statements like this, and we would have to factor out the greatest common factor. Like, for example, on this one, we could say both those coefficients could be divided by 3, and they both have an x in each term. And so then we had our leftover stuff in the parentheses. What's left over if you divide everything by 3 and you take away one of the x's, and we had something like that, right? And so we could factor things using the greatest common factor. On this one, they both could go into 5, and they both have a letter y, right? And so even if it was an equation, we learned how to use the zero product property and use the greatest common factor to factor a polynomial, right? Now, here's the problem, though. What if there is no greatest common factor, right? Like if you look at this, I have a trinomial, but it's not like there's anything in common with all three terms, right? Do they all have x's in them? No, I mean, these two have x's, but this doesn't have an x in it. Is there a number that could be divided into all these terms? No, not really, because this is obviously a 1, and so it's not like a number is going to go into all three terms. There's no greatest common factor. And so what you have to do when there's no greatest common factor, like up here, they could both go into 3. Here, they could both go into 5, and they both have a y. If there's no greatest common factor, you've got to do a little bit of brainstorming. It's almost like a little brain teaser, kind of one of those little mental math trivia questions that you might see. And if you know what you're looking at, these can actually be pretty easy, and for some people, they can be pretty enjoyable. Basically, what we're doing here, if you don't know yet, what we're going to be doing is we're going to undo FOIL. This is the opposite of like FOIL and distributing, right? You remember how we had questions like this? I'm just going to make this up. This isn't the real problem. That you could do with FOIL or the distributive property, or you can make a table, or you could do the big vertical format, right? And this kind of looks like the answers we would get to questions like this, right? Whenever we worked it out. And so what we're basically doing is, instead of getting two parentheses and multiplying or distributing or doing FOIL or whatever to get this as our answer, now we're going the opposite direction. They're going to give us the answer, and we need to figure out what do they multiply together to get this as your final answer, right? And so this is kind of a little brain teaser, but it is fun. So let me kind of show you, let me take the question that I had written down there before I scribbled all over it and put arrows. This is what I had there before I put all those boxes and stuff around it. It's almost like a brain teaser question for those of you all who like to do trivia. In today's, we're only just going to have x squared. There's never going to be a coefficient besides 1 in front of here, and that's going to be something we'll learn later on in this chapter. But this term in the middle, sometimes people refer to it as the letter b. You're looking for two numbers, right? See how there's usually two numbers here in my little example one. There's two numbers that they've put in each parentheses here. We're going to figure out what two numbers would add up to equal positive 9, and then this term at the end is always what it multiplies to. That's the letter C. You can see right here in my little title, you've got a letter C at the end. So basically, what we're trying to do is we're going to try to figure out what two parentheses could we multiply together to get this answer, right? And we know it's got to have x at the beginning because it's x squared. So we know we have to have x and x at the beginning of our parentheses because that's the only way you could get x squared. But now you're going to ask yourself, brain teaser question. Can I think of two numbers that would multiply together to equal 20 that would add up to equal 9? So what numbers would multiply together to equal 20 and would add up to equal 9? Now, most people can think of that in their head. If for some reason you're struggling, you could think, you could just make a little chart here to yourself. I used to have kids in previous years who would make a little chart. We're trying to get 20, and they could say, okay, all the different ways we could get 20. We could do 20 times 1. We could do 2 times 10. We could do 4 times 5. We could do the reverse of all those, right? 5 and 4, 10 and 2, and 20 and 1. And so these are all the multiplying questions. And then I want the combination that adds up to equal 9. So over here, 20 plus 1, that equals 21. If I added them together here, 10 plus 2, that equals 12. Here, 5 and 4, that one obviously is the right combination because 5 times 4 equals 20 and 5 plus 4 equals 9. And so that means our two parentheses here are positive 4 and positive 5. Does it really matter which one is the plus 5 and which one is the plus 4? No. Could I have those reversed? Of course I could. And so you can see how it's a mental math question, but it's kind of an easy mental math question if you know your multiplication facts. What numbers would multiply together to equal 20 that would add up to equal 9? Okay, that's 5 and 4. And then those are the two numbers that go in your parentheses as your end of each parentheses. Okay, let me show you some other examples so we can practice this a little bit more. Hopefully you'll find this as enjoyable as I do. When you get really good at these, you can do them in about 5 seconds each, 10 seconds if they're really tough. Okay, here are 3 examples. Let me adjust that. Example number 1, x squared plus 7x plus 12. Okay, I have all plus signs on this board. We'll eventually get to some minus signs on the next one. So we're looking for what numbers would add up to equal 7, multiply to equal 12. Okay, I like to do the multiplying combinations in my head. So what are my combinations that I know that would multiply together to equal 12? Let's see, there's 1 times 12. That's a 12, doesn't look very good. There's 2 times 6, there's 3 times 4, or 4 times 3, doesn't matter. So out of these combinations, which ones would add up to equal 7? Well, it's not this one. That would equal 13, that would equal 8, that would equal 7. 3 and 4 looks like it. And so that's going to be x, because it starts with x squared, x plus 3, and x plus 4, right? Mental math, two numbers that would multiply together to equal 12, 3 and 4. Those same numbers add up to equal 7. Easy, I hope. The next one, x squared plus 11x plus 30. Okay, so you're thinking of what numbers would multiply together to equal positive 30. And at the same time, if you added those same numbers, you would get 11, positive 11. So if you need to make a little list off to the side, what are all the ways you can get 30? You can. Right? Whoops, I forgot one. 10 times 3. And then which one of these combinations, if I added the numbers together, would equal 11? Over here, 30 plus 1, that's not going to equal 11. 15 plus 2, that doesn't equal 11, that equals 17. Here it is, 6 plus 5. This is the winner right here, 6 and 5. 10 and 3 would equal 13. There should only be one combination. It's got to be 6 and 5. One of the parentheses needs to have positive 6. The other one needs to have positive 5. It doesn't matter the order. Mental math. Hopefully can get us that one. All right, I'll let you try number 3 here. You can pause the video real fast if you think you know it. Two numbers that would multiply to equal 6 that would add up to equal 5. Okay, hopefully you've had a chance to try it. Two numbers that would multiply to equal 6. It's got to either be 3 and 2 or 6 and 1. Those are the only ways to get 6. So if I add those together, which one would add up to 5? This one would add up to 5, 3 and 2, right? Over here, 6 and 1, that would add up to 7, so that can't be it. It's got to be 3 and 2. One of them is 3, one of them is 2. Boom. Now, if you're ever stuck on one of these, you're not sure of yourself, you get an answer and you're like, man, I don't know if that's right. You can always take your answer. Like if I took this answer here, and if I wanted to do FOIL, or if I wanted to do the distributive property, you can actually distribute or do FOIL. If you're a person who does the table, you can draw the table. If you're a person who does it vertically, you can do the problem vertically. Oops, I'm going off my screen here. And then you can work it out. And if you do it correctly and work it all out and multiply it, you should be able to come up with the original problem. You can see here I worked it out. I combined my 2x and my 3x to get 5x in the middle. And this is the same thing as this. So I can tell that I got it right, right? I'm not having to hope that I got it right. I'm not having to guess. I can take my answer and distribute, or if you like to do FOIL or whatever, I can work it out and tell for 100% fact that I got it right. Okay, let's switch the boards because they won't always have all addition signs. What do we do if there are some subtracting signs in there? Okay, it's not going to change anything that we do. Our process is still going to be the same, right? On number 4 here, I'm still looking for two numbers that multiply to equal positive 10. Now see, that plus sign that's in front of it is important. We're looking for numbers that would multiply to equal positive 10, but now look what we're adding up to here. Our sum, or what we're adding the sum has to be negative 7. So that's a clue, right? If they multiply to equal positive 10, but they have to add up to equal negative 7, what does that tell you? That should tell you that both numbers are negative, right? I mean, if I multiply, the only way I can multiply numbers and get a positive answer is to have the signs be the same. And so if I'm looking for negative 7, I don't just want to put like 10 and 1 and then 5 and 2, because those aren't going to add up to a negative 7. Those are going to add up to like positive 11 over here and positive 7. So that's not exactly what I want. It's the wrong signs, right? I need these to add up to negative 7. And so really the combinations I want to try are negative 10 and negative 1, or negative 5 and negative 2, right? So when the last, your C term here, right, your letter C, whenever the C term is positive, but this B term is negative, that tells you that both of your signs, both of your numbers in your parentheses are going to have subtracting with them, right? This is going to be negative 5 and negative 2, because negative 5 times negative 2, that would equal positive 10, and negative 5 plus negative 2 would equal negative 7. Okay, so all of these are going to have two negatives. Let's look at the next one. On number 5, I'm looking for two numbers that would multiply to equal positive 2. So normally I would say, oh yeah, that's 2 and 1, right? Oh, well, hold up. I didn't think long enough. I didn't look here in the middle. These have to add up to equal negative 3. So maybe instead of positive 1 and positive 2, it's negative 1 and negative 2, right? Negative 1 and negative 2, if I multiply those would equal positive 2. Negative 1 plus negative 2, that equals negative 3. So my sum is right. I needed to have them add up to negative 3, and I've got it right here with negative 1 and negative 2. And so that means I've got minus 1 in one parentheses, minus 2 in the other. It doesn't really matter which is which. And there we go with number 5. Okay, you can't see, but this one's numbered number 6. Go ahead and pause the video and try to work this one out in your head for a second. Okay, hopefully you've unpaused it now. I'm looking for two numbers that multiply to equal positive 56. So the signs are the same, positive 56. But they have to add up to equal negative 15. So instead of, when I think of 56, it could be 56 and 1. It could be 8 and 7 is the most common way to get 56. There's other ways as well, I think. 28 and 2, I think, is another way to get 56. But I don't want this to add up to equal positive 15. This has to add up to negative 15. And so what that means is these all have negatives on them, right? Two negatives still make a positive. So which one of these combinations would add up to negative 15? Well, it's got to be this one, right? Negative 8 and negative 7, that would equal negative 15. So it's got to be 8 and 7. So my final answer here is going to be negative 8, or minus 8, and negative 7, which kind of looks like a minus 7 in that parentheses. Okay? All right, we've got one more type of question to go through. Change my board out again. All right, so far all of them that we've seen have had a plus sign at the very end. The C has always been positive. So if you look at these, our letter C, our part at the end, is now negative on every single one of these, right? So that doesn't change our process. We're still doing the same thing. It's still a little brain teaser. Now, though, we're thinking about what numbers would multiply together to equal negative 15. And those same numbers would add up to equal positive 2, right? So if you need to make little notes for yourself, what are all the ways I can multiply two numbers and get negative 15? I could do negative 15 and 1. I could do negative 5 and 3. I could do, if I do reverse, negative 3 and 5. I could do negative 1 and positive 15, right? Excuse me. There are no decimals in this, so if you're sitting there thinking, well, could you do 7.5 times 2? Well, yeah, I mean, technically you could, but there are no decimals in these. So out of these four combinations, which one is the only one that has a sum of positive 2, right? This has to add up to equal positive 2. These two numbers would not. Those would equal negative 14. This would equal negative 2. That's close. So that probably means that it's this one right here, negative 3 and positive 5. This one, I didn't really need to do it since I already found my answer, but that would equal positive 14. So it's negative 3 and positive 5. That would equal positive 2. And so what I want here is negative 3, positive 5, right? Negative 3, positive 5 from here and here. Negative 3 times positive 5 multiplies to equal negative 15. Negative 3 plus positive 5 equals positive 2. So there you go. Our next example, similar situation. We have a negative at the end. This tells you anytime this last term, your C term is negative, you know the symbols are going to be opposite. You know one's going to be a plus and one's going to be a minus, right? So we're looking for two numbers that would multiply to equal negative 32. If you want to make a list, all the ways you can get negative 32, there's a whole bunch. Negative 4 and 8. I could flip all these around, right? When both numbers are positive, it really doesn't matter if you flip them around. But when you have a negative as your answer, you sometimes have to flip them all around just to get your combination. So there's 6 different ways I could multiply two numbers and get an answer of negative 32. I'm looking for the only combination in this list where my two numbers add up to equal negative 4. Negative 4. So here, those, if I add them, that equals 31. That's not it. Here, if I add them, that equals 14. That's not it. Here, if I add them, that equals positive 4. So that's close. That's a sign that I have the right numbers. My signs are just backwards. It should be this next one, negative 8 and positive 4. And those two add up to equal negative 4. These others aren't really necessary, but if you wanted to, just go ahead and knock them out. They're just the opposites of those ones at the top. So it's here, negative 8 and positive 4 are my two integers that I'm looking for my parentheses, negative 8 minus 8, and then positive 4. Okay, we have one more on this board. If you want to pause the video and try this one on your own, go ahead. Otherwise, I'll do it here in just a second. All right, so on this one, we're looking for two numbers that would multiply to equal negative 18, and we're looking for two numbers, those same numbers have to add up to equal negative, or positive 7, excuse me. And you see, I totally messed up the last one. On the last one, I made them y's, but in my answer, I put x's. Sorry about that. Every once in a while, they'll switch it up and give you a different letter. It really doesn't matter. Just don't do a bonehead move like I just did and completely forget. Sometimes I get in the habit of having a whole bunch of x's and I just keep writing x's, even though that's not what the question has. This one has w's, so I'm looking for combinations that would multiply to equal negative 18. So that could be negative 1 and positive 18. It could be negative 2 with 9. It could be negative 3 with 6. It could be, I'm going off my board here. It could be the reverse of all of these, but hopefully I don't need to do the reverse of all of them. It could be negative 6 with 3, negative 9 with 2, and then negative 18 with 1. I don't have room to fit it on here, but hopefully that's not the answer. So I'm looking for the sum that has to equal positive 7. So here, negative 1 plus 18. That equals 17. That's not it. Negative 2 plus 9. That equals positive 7. Oh, this is it right here. This is our answer. Negative 2 plus 9. So that means W, don't mess it up like I did on the last one, W minus 2 and W plus 9. Okay, there it is. Don't let them fool you like I just fooled myself switching it to a different letter. If it's W's, you do it the same way. Okay, one last board. I thought this was the last one, but it looks like I made one more. Every once in a while, whenever the book or the paper or the test or your teacher, whoever, is deciding to be extremely rude, when they are deciding to be extremely rude, they won't put the terms in standard form, right? They won't have them in the correct order from highest degree down to lowest degree. If they decide to do that, you're going to be kind of annoyed, but all that means is you just need to rearrange it, right? You see how this is to the first degree, this is to the second degree, this is to the 0 degree. It's in the wrong order. Just flip it around in the right order, right? This needs to be first because it's to the second degree, second power. And then the 5W is to the first power. That needs to be second. And then the 6 is at the end because it's to the 0 degree. And now it's just like what we have been doing, right? Can I think of two numbers that would multiply to equal 6 that would add up to equal 5? Multiply to equal 6 that adds up to equal 5. That's got to be 3 and 2, right? W plus 3, W plus 2. 3 and 2 multiplies to equal 6. 3 and 2 add up to equal 5. The next one, rude. Again, these are just rude questions. People trying to be disrespectful to you by putting them in the wrong order. This needs to be first, positive k squared, because it is to the second power, second degree. This to the first degree, it needs to be second in your list, 14k's. I switch it to k on this one. And then 48, positive 48 goes at the end. So same idea. Now it's in the right order. Can I think in my head of two numbers that would multiply to equal 48? That would add up to equal 14? Let's see, the most common way to get 48, besides 48 and 1, 12 and 4, that wouldn't add up to 14. How about 6 and 8, right? 6 and 8. Doesn't matter which one comes first and which one comes second. As long as you have 6 and 8 as your combination. There you go. And then the last and the rudest of all, because it starts with a negative. Oh no, it starts with a negative. All right, don't freak out. Same thing. It's in the wrong order, right? This needs to be at the beginning, positive k squared, because it's to the second power. This is to the first degree. It needs to be second. It has a minus sign in front of it, right? So minus 9x. And then the minus 22 or negative 22 goes at the end. And here's our question. Can we think of two numbers that multiply to equal negative 22 that add up to equal negative 9? Okay, how are all the ways we can get negative 22 with multiplying? It could be negative 22 times 1, negative 11 times 2. I guess I could have those flipped. It could be negative 2 times 11 and negative 1 times 22. So if I take these four combinations and I add them together, what's the only one that's going to add up to equal negative 9? Let's see, negative 22 and 1, that equals negative 21. It's not that one. Let me scoot you over here. Negative 11 and 2, that one equals negative 9. Oh, that is exactly what I'm looking for. Negative 9 is the answer I have right here. And so that means my combination is this, negative 11 and positive 2. This is x, negative 11, positive 2. I did it, right? They were trying to be rude. They were trying to be disrespectful. They were trying to put them in the wrong order. Don't let that stuff mess you up. Now you can still do it. Okay, so that's going to be the end of my video for my algebra students. I'm going to put an assignment on the Big Ideas Math website. If you're a person who's not using my Big Ideas Math website, this kudasoftware.com/free.html, I bet you could find factoring polynomials, x squared plus bx plus c is what I would be looking for. I'd be looking for this title right here, factoring polynomials, x squared plus bx plus c. They'll probably have like an easy version and a hard version. I would do the ones that are obviously the easy version. Tomorrow we'll do some more with this because it does get a little bit more complicated. But for now, that'll be it. Thanks so much for watching.